Hello, my name is Nick Verhoeven and I'm a BI and Predictive Solution Advisor here at SAP. And today I would like to speak to you about our predictive solutions. This will take more or less 20-25 minutes, it being a timed webinar. So the first 5 minutes I will get into the analytic solutions from SAP and how predictive fits into the other solutions that Kieran and Sadeshni have spoken about in the prior weeks in this September webinar series. Then I will speak to you about the analytics maturity curve. And in this, I'm trying to explain as well how predictive analytics is more of an extension to your current BI solution than it is a different school of thought entirely. And with this BI maturity curve, this should be much clearer. And then finally, I will spend 15 minutes more or less trying to show you our predictive solution. So I will use a certain scenario. Today I'll be using HR and attrition rate. And with this, I'll be showing our predictive solutions. So let's not dwell on time zones and just keep it simple. So where do we get started? We get started with the bottom. So what you have right here, right next to me, are the data sources. And this is what Kieran spoke about last week. And he spoke about, in SAP terms, EIM, Enterprise Information Management. So in essence, all this is, what we're talking about, is getting clean data. And whatever analysis you might do, the basics for it is clean data. So without clean data, all the other is not possible, as you will see in my next slide, which is the maturity curve. What Sadeshni spoke about as well is enterprise business intelligence. So getting this clean data and spreading it out across your enterprise. So making sure that everyone knows what's happening in the enterprise. And as we all know, information is very valuable, and an educated employee is much better than somebody who doesn't know what they're doing and just decides on gut feeling. And that's our enterprise BI, market leading enterprise BI solutions. Then on top of that, what I will be speaking about today is agile visualization and advanced analytics. And agile visualization is for your exploratory analytics, so getting quick insight into your data. But then advanced analytics moves forward on this. So how does that work? Well, to show you that, I would like to use this maturity curve. So first you have your raw data that becomes clean data, so Kieran's bit with EIM. But then you go forward, you're going to start creating reports, ad hoc reports, and some stuff that we like to call self-service BI. So you spread this insight across your business. Then as a next step, you have agile visualization. Today I'll also be showing a little bit of this. I won't be going into depth on the agile visualization part, but I'm just using it to show you how predictive analytics is an extension to BI. Because when exploratory analytics, you'd be thinking SAP Lumiere, our agile visualization tool. But if you move forward from that and you start thinking about algorithmic thinking, which is a very different way of approaching your data, you might think this is something different from BI, but I'd beg to differ. I think it's an extension to it, because when human comprehension stops, I think that's when algorithmic thinking takes over and becomes the way to go to analyze your data. This might be a little bit abstract, and what I'll do now is I'll get started with my scenario, and after that I'll open up Lumiere trying to handle this scenario, and then I'll show you where predictive analytics, and in this case algorithmic thinking, comes in. So let me hide myself here and open up the scenario for today, being attrition rate. So I found, using SAP Lumiere, our exploratory analytics tool, that attrition rate has risen over the last few months and people are leaving our company, simply put. And I've told this to my boss. I showed him these nice Lumiere graphs and he was very happy to hear, as you can see. And he was so nice today to give me a call as well and tell me, okay, great that we know people are leaving. Now I want to know why they're leaving and who's going to leave next, so we can prevent them from leaving, because leaving is quite a costly operation. So what I'll do now is I'll open up Lumiere, and in Lumiere I have this data set from HR of the last few months of the people that are still in the company and the people that have left the company. In predictive terms, this would be the training data set, and I'll use this data set to find out, or at least I'll try to use this data set in Lumiere to find out why people have left the company. So in this, it's the employee ID, what's their marital status, what is their salary, did they have a promotion recently, and of course the target variable, what we want to know, did they leave their job, yes or no. So let's just open up Lumira and find out, at least try to find out why this is happening. So here you're looking at the Lumira interface that also connects to a variety of data sources, and you can store your files on the BI platform, of course. But now let's just open that data set I was talking about. So you have your employee IDs, did they enjoy an education, their age range, salary, what is their capacity they're working at, the organizational unit, marital status, and then finally, did they leave their job, yes or no, 1 being a yes, 0 being a no. So a classification question to say it's a yes or a no. First thing I'll do is I'll make a measure out of my employee ID, so I can measure how many people left yes or no, looking at the different explanatory variables I have over here, or dimensions. I go to the Visualize tab to do this. I drag in employee ID as a measure, and I will drag in did they leave their job as a color, so I can make comparisons. So here I see how many people are still in and how many people left in this data set. And let's do our comparisons, shall we? So first look at age range. I need to have this done by the afternoon, so let's just drag them all in to see what I can find. Education in there. Are they a chief? Becomes a bit complex to understand this visualization. I'd say it becomes a bit too complex. Adding in the promotion interval kind of makes it, well, I really can't see what's happening here. I wouldn't know what to do with this actually. I need to have this done by the end of the afternoon, and to be honest, I can't make sense of this much data. I can't compare how this would influence the people leaving. It's like, that's where we get into this algorithmic thinking. It's where the human comprehension stops to look at this much variables at the same time. That's where algorithmic thinking becomes relevant. So let's go back to our scenario and see how we solve this with algorithmic thinking and how it becomes an extension to our BI. So back to our scenario, but we go to the next step, and that's predictive analytics. And in predictive analytics, you have a quite simple process. You have to prepare your data set, you have to build the model on top of that data set, and then you apply that data set to new data. Well, this can become really complex if you think about the area of the data scientist. And just to give you a bit of a background here, SAP delivers two solutions. One being expert analytics for the data scientist, where he can really tweak his algorithm and can really build a beautiful model if he has weeks to do so. But then on the other hand, we have automated analytics, and that's the one I'll be speaking about today, because also I am not a data scientist, and what I want to show you is how a non-data scientist can still work with this algorithmic thinking and how it becomes an extension to your BI. So what I'll do with automated analytics is I'll open up the same data set. I will do the preparation steps needed for creating an algorithm, being what kind of value is this? Is this a continuous, a nominal, or ordinal? So what kind of category? What is the storage type of this variable? Do I think this explains the target, yes or no? Binning, so you make categories to continuous variables. These are all things you'd have to do. And with automated analytics, this is mostly a automated process, as you might guess. So how is this automated and how can it be so efficient? Well, we have to thank Mr. Vapnik for this, which is a great statistician that helped create the algorithm that we use in automated analytics. And with this, you can have a great deal of explanatory variables to explain your target without having to understand them all, without having to do statistical analysis on each of them before you can build the model. Because in this example, we're using a fairly simple data set with, say, 10, 12 variables trying to explain the target. So we would be able to do that by hand, probably. But just imagine in the world of big data what we could do. For example, we had this case in our team where we scraped people's LinkedIn pages also to find out why the attrition rate was rising and how we could prevent that from happening. And we scraped all of the LinkedIn pages with the text. So if somebody had passionate for IT, so 3 words on the LinkedIn page, we would have a 1 for passionate, we have a 1 for and 1 for IT. and if somebody wouldn't have those words, they would be zeros. Well, that's only 3 words, but you can imagine how many different words there are on, say, 3, 4, maybe even 500 different LinkedIn profiles. So you get thousands of extra variables trying to explain the target. What you can imagine, this many variables is just not possible to find out if it's influencing it by hand. You need a sort of automated process. So that's where this automated process of automated analytics comes in. And why is this so important? Well, in today's day and age of big data, you have this ocean of noise, and we want to just grab what is useful out of there. And doing so by hand is just not possible. This is where this human comprehension stops and this algorithmic thinking comes in. And what we'll do now is we'll open up automated analytics, where we already have an analytical data set ready, so the one you also saw in Lemira. And you see how these steps would usually take a long time to complete, are very simple and easy to complete in automated analytics. So what I'll do is I'll open the data set, and you see the data encoding happen automatically. So let me hide myself and show predictive analytics again. So what you see here is the data manager where you could create your analytical data set, but we already have one. So what we'll do, Expert Analytics, we'll go to the modeler and see the different models we could create. Note that you do not have to choose an algorithm. You just have to choose a specific business case. In this case, it's a yes or no, so a classification model. Let us point to the source. So it's a text file in this case. It's the same file you saw in Lemira. I could decide on a cutting strategy, but I'm going for the standards. I will analyze my data, and it will find the storage types and the value categories. If it's a key, yes or no. Okay, I'm happy with these standard variables. I think it's analyzed it quite well. And then I will go to the next step, in which I only have to decide what is the target variable, so leaving the job, yes or no, and what should I exclude. Well, think about excluding variables because they're just not useful. So for example, employee ID, because it doesn't explain anything, it just shows who's who. And basically, that's it. That's all you have to do in automated analytics to prepare your data set before you can do and create your model. What it will also do when it starts generating model is automatically sample your data set. So it will create a training data set, so what it's going to use to build the model, and a validation data set, so a little bit of extra part of the data that you have on which it can be compared. So if you build a model, it can use this validation part of the data set to see if your model would also hold up against new data, if we didn't make too much assumptions. And after this data set has been prepared and after it's been sampled, we'll get into building the model. So what you'll see with building the model, that this is a very easy and fast process as well. All we had to do beforehand was just select the variable we want to find and what we might want to exclude. The cutting process is sampling it has already been done. So what it will do, as it will go through the data a few times with different iterations, it will see with what iteration it will have the most predictive power and the model is most robust. So being explaining the variable and holding up to new data, and it will test this by using the validation set. And going through it, saying, no, I want to exclude this, I want to keep this variable. This is all being done automatically. And what you'll see, if you start using automated analytics, you'd probably go back and forth in this, in creating it and finding the right amount of data to build your model. So, okay, the predictive power is too low, so let's add more variables. Okay, the robustness is too low, let's add more rows. And that's the basic steps that you need to take. And for building the model, again, you do not need to be a data scientist. All you need to know is what is this data that I'm looking at. You need to understand it and what is the goal that I'm trying to achieve. So it's better that you understand the business as opposed to being this scientist. So let me again hide myself and open up Predictive Analytics, and let's start building this model. So what I'll do is I'll click Generate. The model gets generated based on the target and variables. I can see the log, what it did to create this model, but I like to keep it simple today. Here you see what it used. So our basic inputs, how it's analyzed the variables, some descriptive analytics, so how many times do we see this target in the data set, and then the predictive power that has come forward from it. So 87 and 96 in robustness, predictive confidence. So that's pretty good actually. We can see the exact same thing in the model graph. So what you see on the bottom is the red line, which would be completely random, the blue line, which is our model, and the green line, which would be a perfect model. So every prediction is good. So what we try to do is get as close to the green line as possible, and you see the different iterations it went through and why it kept the current model. Then you can find the influences. So this is good to analyze your model if it's any good and if the influences make any sense. So if it's positively or negatively affecting the model, then you can see your descriptive analytics, or the test I was speaking about that you usually have to do by hand, which it now does automatically. You can look at the different variables and how they contribute to the predictive power, and maybe some don't contribute enough, or some contribute too much, meaning that they're not really explaining the variable because they came after the variable, so you'd have to exclude them, and those are the different iterations you'd go through yourself. The scorecard just showing the coefficients, not very user-friendly, so we're going to keep out of that one. And the Confucius chart, which is quite good because this is something you can use to see how many positives you have that you've predicted positive, how many negatives you have that you've predicted negative, and with this you can really make a good, a well-educated assumption in how much will it provide me with dollar signs if I would apply this model to the top 10% of probability, being it costs me this much when an employee leaves, and it will cost me this much to give him this benefits package that will keep him to stay. And then you can compare against how many people should we apply this model, which is a nice bridge to go to my next step actually, which is applying the model. So the final step, of course, because now I've been in my little office, I've made this model and I've found out why attrition rate is happening, and I can predict it for future data sets. But then you want to get into this actual prediction. So there's many ways you could apply a model. You could just use it from predictive analytics or automated analytics in this case directly and do a one-off, as we'll do in this example. So you get a new data set to apply the model to. Then it goes to predictive and it goes back as you write the predictive results back. Or you could use Model Manager to periodically apply this model and make sure it's always in the same table so your BI users can find it. So that's your analytical way of applying the model. But what you could also do is you could embed this model. Automated Analytics offers you a variety of ways to export the code that comes with this model, and with this you could embed it, for example, in your cash registers, your point of sale systems. So for a retailer in a grocery store, the one behind the register could see, hey, he bought product A and product B. The probability of him buying product C is over 80%, so it would make sense to offer him product C, and then he would make an extra transaction. And these kind of things make sure people on the work floor using predictive analytics without even knowing it on the background. And also writing it back into a database for the BI people means that all your BI people get access to these predictive algorithms that have been applied to these tables. They don't have to know how it works or what's behind it. All they have to do is just to view that table, and with that you give them the ability to view predictive results, this algorithmic thinking. Or, as you've seen in the tool so far already, it's so simple that I think if you understand your data, which your BI users do, that every BI user should also be able to apply automated analytics in this case. So let me show you how you can apply one of these models and what you could export. Real quick, opening up Predictive Analytics again as well, and then opening up that table that I've written back to the database in Lemire. So let me hide myself again and open up Lemire. So first, where I can run the model, as I will do shortly, I can save and export the model. So generate the code to embed it somewhere, so SQL code, Java code, C code, the codes you'd imagine to be here. I could export a shell script if I want to do it many times, if I want to create really a lot of models in a short time. But what I'll do now is a one-off, so I will point to our HR table in our database to apply the model to. And then what I'll do is I'll choose that I only want the predicted values. I will write that same data back to that same database. So I select the database and I will call this leaving probability. So a new table will be created with this name. And I will click apply and the model will be applied to that data set. I can view the outputs from here, and what you'll see is that you can see the data, the employee IDs, and the probability to leave for each. And that's basically it. I've applied my model for the first time. So what I can do now is a BI user, I can open up my Lumira. I can connect to this table or wherever you would have stored it. So I'm just looking for my table right now. You see there's a lot of users in this database. Preview the data. This is the same as we just saw in Automated Analytics. I have my data here. So gathering my insight in the Visualize tab. So I have the probability to leave per employee. Let me just look at the top. And I see a little spike over here. So those are the main people to look at. I filter those. Create a crosstab as opposed to this visualization here. I can export those results. Export it to a CSV file for this example. I save it there. I email it to my manager. Even better would have been if I created a story in Lumira, of course, and sent him the Lumira file, but just to show you the simplicity of the tool here. And with this, I got this information back to my manager even before he could have finished lunch. So building the model is so much easier in Automated Analytics and also so much faster, because now we can create the model before the employees actually leave the company. So it's nice to have a little bit fast working in these kind of scenarios. And there's so many different scenarios in which you could use predictive analytics. I've looked at attrition rate as it is something that every company could relate to. But imagine if you're a credit card company, you would like to look at churn. How many people are leaving my company month over month and why? And how can I influence this? Who are the people I should give an offer next week so they don't churn? So what does it sound to you if your company would have 20% less churn due to the fact that you can predict who's going to churn next month? Basket analysis, if you're buying A and B, you probably want C as well. So you can do that for whatever your portfolio is. Predictive maintenance. Think about companies, manufacturing companies that have machines going back and forth all the time. And if it breaks down, your production line stops. And this costs you a lot of money. So what would it mean if we can predict something breaks before it breaks, replace it before it breaks, and with this 20% less downtime of your machines? These kind of scenarios is what you should think of, is what is the value of predictive? What is the value of this algorithmic thinking? And the beauty of it with automated analytics is that this has become available to not only your data scientists to create these kind of models, but also for your BI users or your business users to create these models and to play and work with these models. And I think that's the beauty and the power of predictive analytics. For the ones that don't already know, this is part of a September webinar series, and this is the final one concluding the September series. There's an actual other webinar series coming up in October. Feel free to reach out to my email and I will send you the invite to those. I hope you've enjoyed my little demo and scenario in which I've explained predictive analytics. I think 30 minutes doesn't do predictive analytics justice. It's such a beautiful topic and there's so many use cases that you can think of to save your company or to make your company more money. and I'd love to be invited to a talk where we can see what predictive can do for your company. I thank you for your attention, and I hope to speak to you later. Thank you.